Okay, in this video, we're going to be doing Calc AB Problem Set 124. The problems and a playlist are in the description below. Let's take a look. Calculator question. Let R be the region between y equals 30 sine pi over 5x plus 10 and y equals 5 plus 7x above the x-axis. So that's R. R is the base of a solid with cross-sections perpendicular to the x-axis. Find the volume of the solid formed if the cross-sections are equilateral triangles, semicircles with diameters in the xy plane, and then a shape with cross-sectional area a of x equals 5x squared plus sine squared of pi over 6x. Okay, so of these, C seems like the weirdest, but is actually the easiest. But let's start out by figuring out what R looks like. It's a calculator question, so use your calculator. You can see because they're bold, I've already stored some values. I stored negative 0.430263 and 3.74819. And I'm going to use those when I use the calculator on it. So I found the intersection points. I found a good window. I'm ready to go. To make this problem easier on myself and everyone, I'm going to name the functions. So I'm going to say let f of x be the sine function and g of x be the linear function. I'm also, so that I don't have to write those numbers over and over, I'm going to say let a equal negative 4.30263 and b equal 3.74819. So the reason I'm doing that is I can now write my integrals in terms of f, g, a, and b. And I don't have to write all those numbers over again. All right, so with that in mind, the question at this point becomes easy to write down. If you're good with your calculator, easy to calculate. So I'm going to start writing them down. So we need to figure out like S. I always call it S. It's the distance between the curves, perpendicular to whatever axis you're told. So x-axis in this case. So it's going to be top take away bottom, which in my context is f minus g. Okay, with that in mind, let's do this. So A, equilateral triangle, the area of that is root 3 over 4 s squared. So I'm going to do root 3 over 4. I have to integrate the area of a cross section. So it's the integral of root 3 over 4 s squared. So it's the integral from a to b. I stored the values. And then it's s, which is f of x minus g of x squared. So this is all I have to write. But I do have to write let f of x equal this, g of x equal that, a equal this, b equal that. Once I've written it, though, life is easier. I'm going to save the numerical values until the end. Because in part B, we're doing semicircles with diameters in the xy plane. This is one that you have to memorize. Don't mess around with it. It's pi over 8 s squared. So we get pi over 8, integral from a to b, s squared again, which is f of x minus g of x squared. This is why I actually like it when you get asked, like this won't happen on the AP exam, but I like when there's this area with known cross-sections question where they ask like multiple cross-sections in a row because they're all just like some scalar multiple of s squared for the most part. We'll use a calculator on this. Now for C, the shape has cross-sectional area a of x, which is 5x squared plus sine squared of pi over 6x. All we have to do is integrate the area of a cross-section, and we were given the area of a cross-section. So the answer to this is even easier. It's just the integral from a to b of a of x dx. Like, do I know what that shape is? Absolutely no idea. It doesn't really matter, though, because the calculator is just going to find the volume for us. So I did all the calculations, and then I'm not going to make you watch, but each of them should get an approximately equal to sign and 3 decimal places. Pretty good problem. It covers a lot of things that you definitely need to know. All right, question 2. Evaluate the integral from negative 3 to 5 of the absolute value of 2x minus 1. The way that we always handle these in AP Calculus is by graphing. So I'm going to create a graph. The only things that are super relevant are the endpoints, so negative 3 and 5, and the vertex, which occurs at x equals 1/2. So 1/2. 5 and negative 3. At negative 3, plug in, you get negative 6 minus 1 is negative 7, but absolute value, so we get negative 3, 7. At 5, you get 10 minus 1 is 9, absolute value is 9, so you get 5, 9. So we end up with 2 triangles that we're finding the areas of, right? So we need this triangle, and then we need this triangle. So these questions can always, if you're doing the integral of the absolute value of a linear function, you can always deal with it this way, especially on the AP Calculus exam. All right, so our integral is going to be Add up the triangles. So the first triangle is 1/2. The base goes from -3 to 1/2. So that's 3 plus 1/2. It's 7 halves is the base. And then the height is 7 plus 1/2. You're going from 1/2 to 5. So that's 4.5 or 9 halves. And then the height is 9. And then, so you're going to get 49 plus 81 all over 4, which is 130 all over 4, which is 65 over 2. So that's our answer. Handle it by graphing. But we've done so many of those. I don't know how many are exactly in all the previous problem sets, but it is a lot. All right, the next question should also look familiar, but we haven't done it in a while. Evaluate the limit as x approaches 12 from the left of the absolute value of x minus 12 over x minus 12. You have to know what this graph looks like. So I'm going to create the graph. At 12, there's a jump discontinuity. And to the right of 12, like just pick a number. To the right of 12, you're going to get 1 no matter what number you've picked in to sub in. To the left of 12, you're going to get -1 no matter what number you have picked to sub in. So our graph looks like this. We're at -1 and 1. And since we're approaching from the left, looks like that. Our answer is definitely -1. So there you go. That's actually the whole problem set. I hope this was helpful, and good luck.